This example comes out of 10.3 composite functions. This example is slightly different from the last. Starts off similarly in that we're given some functions. In this case, f of x equals 9x, g of x equals 2x plus 1, h of x equals x squared. All, again, relatively simple functions, two linear ones, and one parabola. We're asked this time to actually find a number, an answer to these questions, to say what is f of g of 3. So what that means is you first figure out what g of 3 is. So g of 3 is going to equal 2 times 3 plus 1, which equals 7. Now we're being asked what's f of 7. So f of 7 is going to be 9 times 7, which equals 63. So 63 is the answer to the question. Asked in this way basically just becomes a little two-step problem. So the next one the same way. I'll start with the innermost bracket. Say, what is h of negative 4? Well, that's going to be negative 4 squared. If you need to do that on a calculator, which I hope you don't, make sure you put brackets around it because the answer is positive 16. 4 times 4 is 16. The negatives go away. So I'm really saying what is g of 16? So g of 16 is going to be 2 times 16 plus 1, which equals 33. So the answer to part B, 33. Now C is weird because it's saying h of 5. You can do a function of itself. You could do it multiple times if you wanted to. H of 5 equals 5 squared, which equals 25. And this is saying what is h of 25. So that's just going to be 25 squared, which equals 625. So even without finding what f of g of x is, which we could have done if we said what is f of g of x, we could say, oh, that's going to be 9 times 2x plus 1, and done it all in one step then by substituting in 3 into that. Same way we could have said what is g of h of x for the second example, and said, oh, that's 2 times x squared plus 1. And finally the last one, h of x is going to say h of x equals x squared, then being squared, which gives you x to the 4. And if you substitute in the numbers that you have in A, B, and C, you will get the same answers. We got 63, 33, and 625 if you put them into those functions.